So here we're asked to evaluate each of these logarithms. What we're going to do is we're going to say, I don't know what they're equal to, so I'm going to make them equal to x, because that's what we do when we don't know something. Change it to an algebraic expression. And for right now, you're going to find it much more helpful if you're dealing with exponents rather than logarithms, because you're more comfortable with exponents. So what we're going to do for each of these, we're going to change this to its exponential form. So this is logarithmic form because it's written as a log. Exponential form is saying the base is 3. I don't know the exponent, but I know that it's equal to 729. Oh, I forgot. I'm doing the one off to the side. Here, I'll still go to the one off to the side. Here we go. Sorry. It's 5. So now, 5 to what power is 3,125? Okay, so we'd have to go to our powers chart for 5. On our powers chart for 5, we went up to 5 to the 4, which was 625. So again, we would get 3,125. So what we do is we write both sides, and this is connected to what we did the other day when we're solving exponential equations. If we can write them both with the same base, then we'll be able to figure out what x is. So x is equal to 5. Now technically what we're doing, we did this already and we just went, so x is equal to 5 because we could just see it by observation. Technically now if we wanted to, once we've got them both with a base 5 like this, what we are technically doing, and you never have to show this step, but if you want to, we are taking the log base 5 of both sides, because that is the inverse of 5 to the x. And what's going to happen is this log 5 will cancel out with that 5 and you'll just get x. And this log 5 will cancel out with that 5 and you'll just get 5. But most people at this stage just say, well, it's so easy to see by observation that 5 to the x equals 5 to the 5, that x has to equal 5. So we never practice this step. We just say x is 5. For part B, we've got 6 to what power is 1 over 216. And we go to our powers chart, and 216 is 6 cubed. So what are we going to do with that 6 cubed on the bottom? Bring it to the top using your negative exponent law. And I won't take log base 6 of both sides. I'm just going to write x equals minus 3. And once again, for part C, when you go to the pre-quiz online, or if you look at the textbook answer, they do it in a different way. I find that the way that we're going to do it is based on what we did for the first two, help students find it a little bit easier. So again, we're going to do the same step. We're going to make it equal to x. The base is 8. 8 to what power is equal to 2 times the cube root of 2. And we're going to use the same strategy. Can we write all of this with the same base? Are all of these numbers in the same column of our powers chart? And yes, they are, because 8 is 2 cubed. So we can change 8 to 2 cubed. And here we're going to have 2 times, and the cube root of 2 is 2 to the 1/3. On the left side of our equation, our exponent laws say exponent to an exponent, multiply. On the right side, when we're multiplying two things with the same base, what do we do to the exponents? Add them up. Now, how do I add fractions? I need a common denominator. And at this point, we do have the base is the same. So we're going to know that 3x is going to equal, and 1 plus 1/3 is the same as 3 over 3 plus 1/3, which will just be 4/3. How do I solve for x? Divide both sides by 3. Remember, dividing by 3 is the same as multiplying by 1/3, and I find that easier at this point because when you multiply by 1/3, you've got just multiplying fractions, you're going to get 4/9. Questions you can do here are 4, 7, and 9.